Alrighty, this is the video about paper 2 and it's the first one where I solved the one question that I consider actually to be the easiest. And this time it's quite opposite of paper 1 because the most straightforward question that you should kind of all aim to be able to do perfectly right is in section B. So be aware that yes, it is very, very long. It's 19 marks and it just keeps asking new weird things. But all of the things are fairly basic. And notice that we are allowed to use the calculator, so that will be a major help. So I hope that I can make you realize that this is 19 fairly manageable marks to get. So you can answer one question perfectly right and you're already totally sure to pass. So let's fire up the calculator and have a look at this question. It says to consider a function that is this rational function with a quadratic function divided by a linear function. And it's defined for values of x that are different from -2. And that's already a little bit of a hint, because obviously when x is -2, then we're dividing by 0 and the function is not defined. Question A says to state the equation of the vertical asymptote to the graph. Well, the vertical asymptote to the graph happens exactly in the points when we are dividing by 0. So when we are very close to divide by 0, we get results that can, sort of depends if the numerator becomes close to 0, but in this case it doesn't. So the only places we can possibly have vertical asymptotes is when we get to divide by 0 in this fraction, and that's when x is equal to -2. So for question A, we go to our, I am not really sure if I'm allowed to do this, but where am I? I think it works like this. Yeah, I go to my answer booklet, and I should write in black. And we make sure to fill in those number boxes saying that this is question 8. And then for sub-question A, the answer is really just that the equation is x equals -2. Notice that just writing -2 is not an equation, and unfortunately there is only 1 mark to get, and you only get that if your answer is an equation. So that is for question A. Question B says find the coordinates of the points where the graph of f crosses the x-axis. And to cross the x-axis, we want the function value, that's the y-coordinate, to be 0. So the function needs to be 0, and since it's a fraction can only be 0 if your numerator is 0. So we have this x squared minus 14x. I'm going to try and write that up. Actually, we can put it into the calculator. So we will need the calculator anyway. So we are going to press this y equals button and define the function. So that is x squared minus 14 times x plus 24 and divided with 2 times the x plus the 4. Notice that when you speak with the calculator, you need to say explicitly what the calculations are. You can't just write 2x and expect the calculator to guess that you mean multiplication, the way we can in written language. Also notice how the brackets are very important, because the calculator can otherwise not see how much we need to divide with. In fact, it would divide with 2x and then add 4 by the end, which is completely something else. So we type in the function, and we can already have a sneak peek at the graph. Looks something like this. We might already suspect that we need a bigger picture, because there's clearly some of the graph missing over here. So we can go to the window and say I probably want bigger values of x. If you look at question D, it asks to draw the graph for x between -20 and 20. So why don't we set up -20 and 20 for the x? And then for y, we're probably going to need something like -50 to 50. Then we can clearly see that the graph, well, that was a bit much because now the dip under the y-axis disappears. So probably, and this is always some trial and error until you get something that looks right. I think this is as nice as it gets. Well, when you want the y coordinate to be 0, it's because we want the function to make a value that is 0. And as we said, we just want the numerator to be 0. So in this case, we go to our paper for question B, and we simply solve for x squared minus 14x plus 24 has to be 0. And we could solve this in a paper 1 situation, but now that we are in paper 2, we might as well just go and say I want to calculate, well, I want to find where the graph intersects the x-axis, so I'm going to make a function that makes the x-axis, so that's y equals 0. And then you have both graphs, they're there, and you say calculate, and we want to calculate the intersection between y1 and y2, and we guess around here. Then it finds the first intersection, that is when x is equal to 2, and we can do the same, calculate, intersect between these two, and then our guess, we go a bit further right, and then it finds that or x equals 12. We know for sure that there are no more because it's a quadratic equation, and obviously we could have found these using the discriminant formula or whatever, but we might as well use the calculator. Now it's paper 2. Those are the two values of x, but if you look carefully at the question, they ask for the points of intersection, and a point has 2 coordinates, so the answer to the question would be that it is in 2, 0, and in the point 12, 0. Those are the intersection points. And again, unfortunately, there are very few marks to get, and you lose far too many of your marks if you just give the answers 2 and 12. Back to the question. So that was for the intersections with the x-axis. Now it says that the graph of f also has an oblique asymptote of the form y equals ax plus b, and we have to find a and b, and they're rational numbers. So finding an oblique asymptote, for that, we set up, I have the expression here, we set up the division, because we want to find out, let's go, was it 2x plus 4? So we actually divide and see what should I multiply 2x plus 4 with in order to get x squared minus 14x plus 24. And if we fire up the division algorithm on that, so really the calculator doesn't help much here, then first we want 2x multiplied with something to get x squared, so we take 1/2 times x, and then we multiply that on our divisor, so we get x squared when it multiplies here, but we also get plus 1/2 times 4, that is 2x, and then we calculate the difference to find what's missing. So x squared goes away, and we have minus 16x, because we're sort of subtracting this. Plus 24. And now we ask what should this be multiplied with in order to get minus 16x, and the answer is minus 8. So minus 8 times 2x gives me minus 16x. minus 8 times 4 becomes minus 32. So we get a reminder, again we're subtracting, this minus 16x go away, but we get 24 plus 32, which is 56. And the upshot is that the x squared minus 14x plus 24 can be almost factorized as 2x plus 4 times 1/2 x minus 8 plus a reminder of 56. Or if you divide by 2x plus 4, you realize that the division just removes this, and then we get divided with 2x plus 4 over here. And the point is that from that we can see that when x goes to infinity or minus infinity, this reminder term has a constant numerator and a denominator that becomes infinitely large. So this guy will approach 0 for large values of x, meaning that the function value of our function becomes more or less the same as this part here. That shows that the asymptote has the equation y equals 1/2 x minus 8. So the a they ask for is 1/2, and the b they ask for is minus 8. And we can also put this line into the calculator by saying y equals 0.5, let's do it like this, 0.5 times x minus 8. And if we do that and look at the graph, we can sort of check that it looks absolutely right, that the graph is approaching this oblique slanted line as x goes to plus or minus infinity. Now, question D says we have to sketch the graph for x between minus 20 and 20, clearly showing the asymptotes and any intersections with the axis. So the intersections with the x-axis we already have, but there is an intersection with the y-axis that happens when x is 0. So for D, I might want to first calculate that f of 0 becomes equal, oh sorry, you can't see my paper. There. And I want to look at the function. F of 0, when you put in 0, we get 24 over 4, because most of all the x terms, they become 0, and that is equal to 6. So the y-intercept is at 0,6. And then we have to draw the graph. So we make a neat, well, let's make it symmetrical, a neat coordinate system. And we start by finding minus 2, because that's where we have a vertical asymptote. And we find 2, because that's where we have an intersect with the x-axis. And we also find 12, because there we have another one. And of course we should go all the way to 20. So let's say 20 is out here. It's also a good idea to add the asymptote. The asymptote goes through, so if we say 6, the intersect with the y-axis is here, then minus 8 is a bit further down, so minus 8 is down here. And this asymptote has a graph that is sort of, no, that's probably not, well, it is, because it needs to go here. So let's try again. Let's start a bit higher. Like that. This is our asymptote. So what the graph does is that it goes along this, goes down, intersects the y-axis, intersects the x-axis, turns around, intersects the x-axis again, and then follows the asymptote. But then it's important to remember that that's only half of the graph. There's another half that goes similarly around these two, so down here. And that is what we should make sure to have the right axis intercepts showing. We should even write this is the line x equals -2, and this guy here is the y equals 1/2 times x minus 8, showing both asymptotes. Let's make this one a full line as well. Well, that was really pathetic. Let's do it. That's almost vertical. So yeah, that is the graph in point D. Then, oh, come on. Question E says find the range of the function. And this is a point where it's really nice to have the graph. So if you look at the calculator, the range is the values of y that the function makes. They are the y coordinates of the points of the graph. And we can see there are infinitely large values of y, and then we get all values of y until we reach a minimum. And here seems to be the locally smallest value of y, because then it starts going up again. But we also get some negative values of y that are very small. In fact, they can be infinitely negative. But there is sort of a local maximum. So it would be nice to have exactly the value of y, that is the local maximum value here, and the value that is the local minimum here. And that's what the calculator can easily do for us. So if we go and calculate, and we say find maximum, and we choose a left bound, and we have to go. So this is a bit annoying because I can't see where I am, but now I'm definitely on the left side. And then I move to the right side, and I move slightly left and guess. Then the local maximum, that is when x is minus 9.48, that's completely irrelevant. What's important is that the y coordinate is equal to minus 16.483. I take plenty of decimals on this, and so on. And the local minimum, we can also find that quickly. Calculate minimum. I have to go on this side, left side, right side, and then we go a few steps backwards. The local minimum, that's when x is 5.48, and the y coordinate is y equals minus 1.51665, so on. And what we want to say for the range is that the range is the values of y for which either y is smaller than smaller than minus 16.483, or, so we can end this and say union with the values of y that are larger than minus 1.5, and so on. Or you could say it's the interval from minus infinity to minus 16.483 union the interval from minus 1.516 and so on to infinity. Final question says solve the inequality. We want f of x to be smaller than x. So x is a function, a very simple function, but we can put it in, and maybe we're not so interested in the asymptote now, so let's just remove that, clear that, and then we make a function that y equals x. Then we draw the graphs. Here is our function, and here comes the graph y equals x. I can sort of say that I want maybe slightly smaller values of both x and y here. So I go and say, let's go to minus 25. Stop that. Minus 25. And for y, we also go to minus 25. Doesn't change a lot. But now we can clearly see that the values we want are the values of x, where f of x is smaller than x. That means that the graph of x has to lie below the straight line y equals x. And that means that we want sort of the values, maybe you can see my cursor, the values that are here, the x-coordinates of these points, because we are below the line, all the way to x equals, or 2, minus 2, but not including. But then if we go to the other side, then suddenly f of x is larger, and then we want to go to the intersection point here, wherever that is, and then the values that are above that. So we can sort of say we want the intersection points first, and that's always how you solve an inequality. You start by solving the equality. So let's say calculate calculate the intersection between this function and this function, and my guess would be around here. Then I get the intersection. So for question F, we have f of x equal to x happens when x is approximately 1.25, or let's find the other intersection. Intersect this curve and the x curve, and then we go somewhere down here and guess x is approximately minus 19 point, let's say 2, because we're rounding to 3 significant figures. And those are the values where we have equality, and then we look at the graph and realize that f of x is smaller than x either when we are in the interval between this minus 19.2, so we don't want to include it because there we have equality, and the inequality is a sharp one, so we want to go from but not including the minus 19.2, and then all the way up to minus 2, but not including, because we don't have a function value there, union with anything from this 1.25 to infinity. And that's the answer to the inequality. And that's actually it for question 8. It was very long, but everything was smacking things into the calculator and getting the numbers we need. So I hope you realize that this is fully available